Okay, we'll go ahead and get started. I'm happy to present Mariana Cains. She's a project scientist within MMM's Weather Risks and Decisions in Society group. Mariana joined NCAR as a postdoc in 2021 after completing her environmental science PhD from Indiana University. Her risk analysis interests have led her on a path through human health and ecological risk of land use, the role of human factors in cybersecurity risk, and integrating climate risk and resilience for regional adaptive management. Most recently, as an NCAR postdoc and now project scientist, Mariana has been exploring how and why environmental risk information becomes both useful to and used by decision makers. And with that, I'll turn it over.
All right, hello everyone. So before we get into the exciting research, I figured since this is the first time a lot of you have seen me in person, I'd give a little background about me. So here is where I'm from. I'm from the great state of Washington. And while I do not have the Flatirons as a background, every day I have Quartzsite Mountain and living in Chewelah Valley. So it is a beautiful place to live. And if you want to visit, let me know. We'll pick something up. All right, a little bit more about me. So for the past several years, I've been working at the intersection of people and the environment, and specifically the assessment of environmental hazards. And with those hazards, I think of it along the chain of climate to weather to physical stressors to impacting people. And with people, I've been looking at the public, local community, and decision makers. So how people use environmental information to make decisions, and you don't need a decision maker in your title to be a decision maker. We are all decision makers. And with my environmental hazard work, a lot of it has focused on social vulnerability analysis, environmental risk analysis, and adaptive management frameworks. So as a sidetrack of that in grad school, I was asked to join a team that was looking at the adaptation of environmental risk theory to cybersecurity risk. So this was in 2016 to 2021, and the idea was, how can we borrow from existing risk theory from environmental science, public health, to cybersecurity risk? Are there lessons learned that we can apply and we don't have to, quote, reinvent the wheel? So these are some of the papers I've been a part of those past years. Then, for my dissertation work, I focused on all the buzzwords: place-based risk and resilience assessment of socio-ecological systems and climate change hazards, which doing this dissertation really underscored that the need for risk information has to be driven by the resources available to the decision makers and the community's willingness to actually implement with that risk information. During my time at Indiana University, I also served as the technical lead on the Hoosier Resilience Index and Readiness Assessment. So this is basically an effort to work with city and county officials to help them understand what are their unique vulnerabilities and resilient efforts to both weather extremes and a changing climate. And because it was Indiana, we don't say climate change, we say a changing climate. So, all right, I told Morris there was a picture of him. Can you find yourself, Morris? Whoever finds it gets a cookie. They're out there. So the reason I have this is because it was in the later portion of my grad school that I was first exposed to NCAR, and that was through the 2019 Advanced Study Program Colloquium that was titled Quantifying and Communicating Uncertainty in High Impact Weather Predictions. And the reason that I show this is because this showed me that there are places that are integrating environmental science, social science, talking with people, what are the needs of decision makers, and how do we actually connect what we're doing as an institution to the needs of the public. And my last point on this slide is there were 22 students involved in this, and since 2019, I have either worked with or stayed in contact with 15 of them. So it's a pretty good retention rate, and it's also a big plug to NCAR. Continue to invest in the students this way. So, okay, last little bit before we get to the main event. So since being at NCAR, I have, both as a postdoc and a project scientist, I've led and contributed to research that takes a convergent and a user-engaged perspective on how we're framing and developing environmental information for decision makers. So on the left, we have things associated with how do we integrate climate change into ecological risk assessments, given that the stressors of of climate change versus, say, the impact of pollution are very different. And then on the left hand of the screen, we have the NSF NCAR Earth System Science and Technology Hubs, or NEST. So coming soon will be the phase 1 report of this effort, which is really to understand what is the potential role in space that NCAR could have in place-based and community-driven research. And the reason why I'm highlighting this here is this is an excellent effort of what it means to actually talk with a community affected by your decisions and gather their opinions and actually act on them. So those are sticky notes that we've gathered from community workshops, and this is an effort of over 2 years. Okay, we made it through the previews, and now for the main feature. So today I'm providing an overview of the work that I've been involved in for the last 3 years as a member of the risk communication team, a part of the NSF AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography, AI-2ES for short. So I'll be providing an overview of some of the research that the risk communication team has done, as well as a deeper dive on the newly accepted paper in Weather and Forecasting titled Exploring National Weather Service Forecasters' Assessment of AI Guidance Trustworthiness. All right, so as you can see from the headlines here, and really any smattering of headlines when you open your phone, AI is here and it's receiving a lot of attention in the media, but also in research and specifically the Earth system science domain. So along the bottom here, these are just 2 graphics that are showing the steady and consistent increase of AI and machine learning publications through AMS, and then also through AGU meeting abstracts. And in addition to the media attention and then the growing presence within the sciences, trustworthy, and I'm using quotes on that, so trustworthy AI has gained a lot of traction as a frame in policy, a frame in research, funders, and also with private sector. And even in the name of the long institute that I just read off to you, but what do we mean by trustworthy? And what do we mean by trustworthy AI? And my hope is that by the end of this, you'll know that it's more than just a buzzword and that you will walk away with not the answer to what is trustworthy, but a answer for what could be trustworthy. All right, so the AI-2ES Institute, it started back in 2020, and it had the goal of integrating environmental science, AI, and risk communication, all while also including with broadening participation and workforce development. And the risk communication team that is a part of the risk communication effort here, we have the one, the only, Julie DeMuth. We have then the co-lead of risk communication was Ann Bostrom out of University of Washington. We have the lovely Chris Wers, myself, Jacob Bradford out of Sierra, and then Miranda. So the green highlights are signifying those at NCAR, and Miranda gets an honorary green highlight because she's here working on her dissertation with people with an M-cubed, sizzle, and all that jazz. All right, so what are we doing as the risk communication team? What are our goals? So our goals are to identify factors that influence trust in AI for professional user groups, so those who are using the information in a professional setting. Also to determine how AI trustworthiness influences risk perception and then the use of that AI by the users. And then third, and to inform the development of trustworthy AI approaches for improved decision-making. So it's not just we're using AI to make decisions, but is AI actually doing a value add in the decision-making process? So some of our early on work, this here is showing a highlight from a workshop that the risk communication team led about 2 years ago, and we brought together a wide span of scholars looking at trust and risk, and not just within the environmental science space, but it was in the policy space, within ocean management, within psychology. And what came out of here was a research agenda for AI and environmental science, and that's summarized on the left. So essentially, there needs to be better ways in measuring trust in AI, as trust is a dynamic and contingent process. Also, better understanding of which contingencies and contextual factors matter. So this context, you'll see that carried through this presentation. And then third, trustworthy AI or trustworthy standards and calibrations of trust, they need to be closely scrutinized with empirical evaluation. So not just making a checklist because you think that's what trust is, but actually testing it. And then fourth, integrating knowledge learned in risk and uncertainty communication studies of trust. So There are other domains that have looked at trust. They have looked at risk. Let's learn from them, like I said in my cybersecurity quick update. Lessons learned rather than reinvent the wheel. We also have here Chris leading the charge in reconceptualizing what is meant by trustworthy AI and how trust isn't just a checklist, as I said before, but it is perceptual and also context dependent. So this is currently out in review for the Journal of Artificial Intelligence, and talk to Chris. He's got great things to say about how it's not just what you think trust is, but it's what the person who's actually needing the information. All right, so AI techniques, as we have seen, they've been increasingly used to produce not just new information across domains, but specifically within weather, new guidance tools, and it's the goal of aiding forecasting. So what I have here is an example of a general approach of when you have an interdisciplinary research team. So here, environmental scientists, atmospheric scientists, and AI machine learning developers. You develop a technique, a tool, an algorithm, and then it is used for weather information and then ultimately weather products. What we are doing within the risk communication team is we're taking a convergent science approach. So this has an intentional cross-domain collaboration, which is needed because we're actually trying to address scientific and societal needs. So not just what is interesting, but what is interesting and what is needed by decision makers. So what's different? Risk communication, we are in there as scientists. We've added social science methods. We've included the end user. We've included the people making the decision. And then also we have determined trustworthiness by a user definition, by what the people are using it to make the decisions for. All right, research questions. So you got all that background, and the work that I'm gonna be presenting is basically it's on how do we develop a fundamental understanding of human behavior regarding expert decision making and risk assessment. So our first research question was, how do forecasters decide what model guidance and other tools to use in their operational forecasting process? Research question 1. And then our second question is, how do different descriptive and performance attributes of a prototype model guidance that was developed using AI influence the forecaster's assessment of its trustworthiness? All right, so I'm gonna provide you an overview of the process that we take to do this. So we use a user-centered approach, and we do this because we believe that it better meets forecasters' needs and actually produces guidance that is not just needed by the forecaster, but that they will actually use. So on the left here, these are a sample of some of the different AI-derived weather products that we've been interacting with for the last couple of years. So we have probability of storm mode using convolutional neural nets. We have probability of severe hail using random forest, probability of a coastal fog using 3D convolutional neural net. We have the loop current in the Gulf of Mexico, and that is using a foil neural operator. And then we also have a P-type here, which I don't remember what the machine learning is on that. Do you remember, Charlie?
It's a standard neural network, or an evidential neural network.
Evidential neural network. Thank you, Charlie. All right, so we have our model. We then also have our interview protocol. So what are the questions that we are wanting to ask the end user? We have our interviews with the forecasters. I don't want to update right now. I have 10 remaining. I should be okay. All right, so we have our virtual interviews, which then we, from there, let's see, messed up my advancing. There we go. So after our interviews, we have our interview transcripts. From our transcripts, we then have various methods for content analysis. So we see a nice linear progression. That's great. What really matters is that what we learn from the content analysis of what forecasters deem trustworthy is then integrated back into the model and development, which has been done. So the storm mode, the probability of storm mode product, that was then, after our interview cycle, our feedback was integrated into the next hazardous weather testbed iteration. So a perfect example of information learned, then information used. All right, so today I'm focusing on the paper that's going to be in WAF, and that has been published by myself, Chris, Julie, Ann Bostrom, DJ Gagne, Amy McGovern, Ryan Sobash, and then Deanna Madlenbayan. So as I mentioned before, these two products one, they're focused on severe convective weather. The first is a convolutional neural net model, and then the second is a random forest model. So we're doing probability of storm mode and then probability of severe hail. So we conducted one-on-one interviews with 16 National Weather Service forecasters, and this was from across the central, southern, and eastern region. And the regions that we selected for the interviews were based off of the climatology of the hazards that were being forecasted. We interviewed 7 general schedule meteorologists, 4 lead meteorologists, 5 science and operation officers, and then the distribution, we had 9 of those forecasters reviewing the storm mode and then 7 reviewing the hail. And this was conducted from October 21 to May of 22. Something that I want to underscore here is that these were one-on-one interviews. So it was the forecaster and me or the forecaster and Chris. All right, so this is our map that we're going to use for the rest of the presentation to walk through. And it provides an overview of how we've done our pre-interview survey. So this is a survey just to get an understanding of what are some general understandings of how forecasters want to interact with their guidance data, what information do they want to know about it in a familiarization or training setting versus what they would want to know about the guidance in an operational setting. Then we have our output, which is a frequency analysis of their rating. And then we have the interviews, which were all analyzed using content analysis. So first for the interviews. So we asked the forecasters to think about an actual severe convective event that they recently went through when they were filling out the survey. And the reason for that is we wanted to have their answers tied to a contextually relevant event. So we had 20 survey questions, and these were inspired by previous research on AI, explainability, interpretability, transparency, and performance. But then we modified the questions to be within the context of severe convective weather and forecasting. So they had a series of questions, and they were supposed to say whether or not this type of information was essential, useful but not essential, or not necessary. And we asked that in 2 settings. One, during a familiarization stage or a training stage versus operationally when they're on the floor forecasting. And then for the interviews, we used a think aloud approach. And so a think aloud approach, it has the forecasters verbally share what's going on through their mind and verbalizing it. And the idea is that you don't self-edit, you don't analyze or justify your thought. It's just what's going through your mind. And so we did that in a 2-stage step. First, we gave them initial background information on the guidance, just 1 slide, and asked them to read it and think aloud as they were reading the information. And they told us things that they were interested or concerned by, or like, oh, I don't know what that word means. And in this section, we asked them to rate the trustworthiness of this from 0 to 1 with just 1 piece of information. Then we go to an informational board here on the left. So on the top half, you see where we have these sticky notes that run along the bottom that are describing 6 attributes of the AI. So the technique used, the training of the AI model, what input data was used in that model, how the model verified, the developer, so who made it, and then also a comparison piece to like this one was here for hail, comparing it to the SPC hail outlook or forecast. And as they go through each sticky note, we ask them to, again, think aloud, but then come back to this board and say, oh, this information had no impact on my perceived trustworthiness of it, or it totally tanked it in a decrease, or it increased it. And on this slide here, I'm going to play a video that looks like it's not playing. And the reason why is because the audio to it is the forecaster talking through the process. And because this is human subject research and there are ethical considerations, your voice is an identifiable piece of you. So I will be narrating what the forecaster is saying as they are going through the slide. So,
can we trust that?
Can you trust it? Try to get me at my own game. All right, so forecaster is reading. The machine learning approach used for this guidance is called convolutional neurologist network. The key component of CNN is a set of spatial filters that can detect relevant patterns. These filters are similar to those used for smoothing or neighborhood averaging. I think I like where this is going because I don't really like noisy data. Okay, accept the weights, hold on, let me go back. We're gonna pause here. Accept the weights and the filters are learned. Yeah, that's good to me because it's not static. Our weather is definitely not static. Our atmosphere is anything but static. Okay, let's go. All right, the algorithm developed with the supervised learning and classified by a human. Well, hey, that seems trustworthy to me, that the technique is actually involving human input. Now I'll go back to play it. So you see him, he's dragging it over and he says, it would increase the trustworthiness for me because I found out that there's human input. Trustworthiness for me because a human is involved. All right. So that's how we collect the information, is we have an audio and a video screen record of it, and we can see what they're saying when they're looking at specific pieces of information. Okay, that slide should not be there, but that's okay. So that's your overview of how the data was collected. We had the interview, pre-survey, asking the general of with familiarization versus operational. We then had the interviews, which got to nitty-gritty of asking them specific questions, them interacting with the product, and now we get to the results. So for the pre-interview survey, what we have here are all of the attributes that were deemed essential by at least half of the forecasters, and this was for both the familiarization context and the operational context. So what is essential? Being able to compare the guidance with observations, knowing what the failure modes are, how does the guidance actually verify, how does the guidance verify compared to other guidance, being able to interact with the guidance, get your hands in, play with it, and then being able to sample the product to see how the inputs are actually yielding the outputs, and then also knowing what the input variables are. Then for specifically, this is the familiarization and training portion, we have all or most, nearly most of the forecasters indicated that it was essential or useful to know why the guidance works. Why is it doing what it's doing? Then also knowing how the output was derived and what data was used to train and calibrate the AI. And then last here is being able to examine past predictions of the AI, so past cases. And then the last portion here, these are specific to the operational setting. So there were two attributes that were deemed essential or useful by most of the forecasters. And this is being able to compare the forecast from AI guidance of similar guidance. So similar guidance that you're used to for the same ballot time. And then last here, being able to see the evolution of the guidance over time. So not just a static image, but how is it doing moving through? Okay, so now to the content analysis results. Buckle in. All right, for our research question 1, which was how do forecasters decide what model guidance and other tools to use in their operational forecasting process, we analyzed 2 of the questions from our interview. So the first one was, as a forecaster, you work in such an information-rich environment. You have a lot of tools and guidance at your fingertips. How do you choose what you do? Second, we asked, sometimes guidance may seem like a black box where you don't know how the output was derived. To what extent do you need to know the details of how the product was derived in order to use it for forecasting? So I'm stopping for a little pause here to talk about the method that we use to analyze the text. So we use reflexive thematic analysis, and this emphasizes the researcher's reflexive engagement with theory, data, and interpretation. So I was the tool being used to do the analysis. My brain looking over all of the data that we had, the theory that we understand of forecasters' guidance use, what we know about trust, and it is done through inductive coding. So I'm just showing here an example of how this is just one passage, one paragraph of forecasters one's response to that first question of how do you decide what to use? And you can see as I'm reading through here, I'm picking up on specific themes, and they are then building an inductive code. So personal experience with the product is being built from when he says, for me, my past experience, the biggest thing, experience with guidance. understanding comparative performance of a guidance is being built from models handle different events differently. There's different types of setups, better than others, different data sets at different time periods. And then record of model performance, that's based off of them saying, experienced forecaster over time. I have a mental catalog. It's probably going to do better, seeing the verification statistics. So those are all snippets of what was said that are then built to make the inductive codes, which then make the resulting themes. All right, so I'm only showing a few themes from this analysis. Again, nitty gritty, go into the paper. So our first theme for this question is that forecasters want to understand guidance to use it, but what constitutes understanding is complex and multifaceted. So we have here forecaster 11 saying, you gotta know how things are put together and how they're made to have a deeper understanding of what it's giving you and why it's giving you what it's doing. So I think understanding how a model works is essential. There are probably degrees of how much you need. And then a second theme from this is that forecasters go through an iterative process of exploring and evaluating guidance to determine whether, when, and how it should be used during operations. So here we have forecaster 2 saying, somebody can send me a white paper, hey, check it out, look at this video, and all that. That's great. The model worked great for whenever that study was done, but until I actually try it for a couple of times myself personally, I don't necessarily believe it. All right, on to research question 2. So how do different descriptive and performance attributes of prototype model guidance developed using AI influence forecasters' assessment of the guidance trustworthiness? And so this is looking at the impact of the initial background information. So remember, we had a 2-phase. We showed them one piece of information, asked them to respond to it, give us a trustworthiness ranking. So this is just that one piece of information. So our themes out of this were very much that forecasters apply their own conceptual model of the atmosphere when they're initially making sense of new guidance. So we have forecaster 10 here saying, this visual makes sense to me. This is what I would expect from a conceptual model of how I would expect the storm objects to evolve. This first image is something I would think would be initially trustworthy based off of what I've seen. There's nothing here that would set off any alarm bells that would make me think, oh, this literally doesn't have a clue what's going to happen. So conceptual model of theirs matches what they are seeing with the output. Another theme from this research question is that forecasters want additional baseline information about AI model development to better understand it, particularly the AI techniques used, the model inputs, and how they are defined and how the model outputs are derived. So here, forecaster 16 is saying, how is the AI model defining what the storm object is? I can see from radar underlay that there's areas of convection that are not defined as an object. So I want to know what's going into defining some of these area objects. So this is also, while this is them wanting more information, we see that it's also them applying their own conceptual model of the atmosphere to be like, hey, we need to gut check this. All right, so this is now moving on to the phase of our pre-post trustworthiness. I've been leading up to this. So on a scale from 0 to 10, how trustworthy is the guidance based on the information provided? So remember, we have only one slide of information provided, that's the spin up, and then they go through their whole think aloud and they provide us their ranking or their rating again after they've gone through all 6 attributes. I'll let you sit in, soak this up. So what we have here are the circles on the left are where the forecasters started after they saw one piece, that one slide of information. On the right, with the arrow, you can see that is their final score after they've gone through all 6 pieces of information and the whole slide deck. So we can see that some forecasters, they start off all the way at 8. They're like, they love it. And then they just get nudged up 1 point once they see more. We also have forecasters, like down here on the bottom left, forecaster 8, they started as a 2 and they nudged to a 3.5. We didn't tell them that it had to be integers. We said, what was your rating? And many people are like, 1.5. But what is interesting on here, if you guys haven't caught it, is we have these 3 forecasters that are only triangles. And that's because that one slide of information was not enough for them to determine the trustworthiness. One person says, this isn't enough. How would I know what this is actually doing? And what I think is very interesting is that forecaster 9, they didn't have an initial rating, but after they saw everything, they were pretty gung-ho at a 9 of rating itself. The other takeaway from here is no one is at a full 10. Nobody said, yes, let's roll with this tomorrow. So what does that mean? There's something else missing from just giving them information about the product. So those numbers are the what, but we want to look at the why. Why did they select those ratings? So I'm going to highlight forecaster 2, but note that this type of analysis was done on all of the forecasters' ratings. So forecaster 2, after they provided their rating of 4, they said, I don't know what went into the model necessarily, what the synoptic conditions are, or haven't had any experience with it up until this point either. So it'd be great guidance, but I would want to verify it myself and that it made sense with my conceptual model of what's going on. All right, so they were at a 4. Then they went through the whole slide deck, they thought aloud, and then we get to their ending result, which you can see this is one who decided not to select an integer. They're at 7.5. So they start with, I would go 8 now. I'll just say I wouldn't completely trust it. I know that machine learning can get spurious results, but since I've only looked at basically 2 cases here, I don't have the long background experience information to bump it up higher. So knowing what's behind it and some of the verification, definitely somewhere between 7 and 8. But I would need my own personal experience with it to trust it further. So what I think is interesting about here is they started at 8, then they're talking out loud, and then they realize, I'm gonna bump it down a little bit. So you can see their active thought process while they're giving their rating themselves here. Okay, so this is a high-level summary of basically the themes that came out of those trustworthiness rings as they were talking about why they rated it initially and then why they rated it at the end. So a quick glance over here, you can see that before the think aloud, we had people in the low, moderate, and high. After the think aloud, it was only moderate and high. Nobody rated it a low trustworthiness. But when they only had one piece of information, the reason it was rated low is because they didn't have enough information about the model. And that intuitively makes sense, right? One piece of information, do you trust it? Well, no. And also in the moderate section, so this is an increase with the trustworthiness, the reason why it was rated higher is because it made sense climatologically, it matched their conceptual model, and that the output looked realistic. So what I think is interesting here is while in our pre-interview survey, those questions were based off of the literature for interpretability, explainability, and transparency, we translated that into being relevant for forecasters, and we're seeing a match. We're seeing not a one-for-one match, but the output looks realistic. So forecasters identified that in the survey as being essential for them, and that also stands true when we do the interview. So we're triangulating on what makes something trustworthy for these interviewed forecasters. And then last, I want to highlight the after think aloud. So why did people put it in the moderate and high? And all of those bullets correspond to all the information that we provided on each of the slides. So they liked that there was more background information, that they were familiar with the input data, so the WRF and href, that the comparison looked similar to the conventional resources that they're using, the SPC, that the developers who developed the models had operational and domain expertise. And then last, the reputation of the developer's institution. So we can pat ourselves on the back a little bit because several forecasters are like, oh, NCAR. They know what they're doing. Trust but verify. Okay, so the latter part of the interview, once they went through all of that descriptive information, we asked them, okay, we only selected a few questions, a few attributes. There's plenty else out there that we could provide you. Now that we've provided you some information about this product, is there anything more you'd want to know or be able to do with it before using it for forecasting? So again, we went through the whole reflexive thematic analysis, and these are just a few of the themes that came out of it. So we have the first theme here, forecasters are continually learning. They seek training and reference material to understand guidance, but also require hands-on experience with the guidance. So here we have forecaster 14 saying, but even using new guidance once or twice doesn't increase the trustworthiness. It's got to be multiple cases that I've used myself to get my trustworthiness above whatever I call the standard or whatever my starting point was. We also have the theme that forecasters want to know how the AI guidance and products will improve weather forecasting. What is the value added and what need is being met by this guidance? So here, Forecaster 8 says, is what we're seeing now operationally a result of AI machine learning integration, or is this new approach something totally groundbreaking that we need to look at, that you're looking into improve our forecast? So yes, you can do forecasting with AI, but is it improving beyond the conventional and traditional methods used? All right, so we've covered all of this already. But now we're gonna put a bow on it. So when looking across all of the data, the survey, the interview, the think aloud, the main takeaway that I want you to walk away with is that National Weather Service forecasters' development of trust in AI is a deliberative and dynamic process. Assessment of AI guidance trustworthiness results from iterative, intentional engagement with the guidance. So in doing this, this is looking across all of the data, we saw 3 phases in which the forecasters evaluate new guidance, and it's in different ways. So the first is initial exposure and orientation to the new guidance. So we saw that reflected in that spin-up information, that single slide of information they had. Then there's further familiarization with the guidance through non-operational information seeking and integration. That was them asking questions, wanting more information as they went through the Think Aloud informational board. And then third is operational experience through real-time observation of guidance and potentially use of it for forecasting. So that's at the end. The forecasters were saying, this is all great that I have this information, but I need to use it on the floor to know whether or not I'm actually going to trust it for forecasting. And of course, everything has caveats. So these phases may overlap and they're not necessarily a linear progression, but each part of these we have found to be a key part of the forecaster's assessment of trustworthiness. All right, so this is where we started. We have AI models. We develop a specific interview protocol relevant to the AI model, relevant to the decision-making space of the interviewee. We conduct the interview one-on-one. We have our interview transcripts and our videos. We then do content analysis, feed it back into the development of that product. This is my favorite slide of the last 3 years of research. Forecaster 12. I appreciate you guys getting in touch with all of those weather forecasting office forecasters. And I think that's probably one of the things that's going to make stuff more trustworthy too. It's always nice when people working at national centers reach out to us. I think that makes it more trustworthy. When a forecaster is using a product, if they know that, hey, other WFO people have given their input on this. So I leave you with that, and I thank you for your time.
Do we have plenty of time for questions?
Thanks, Mariana. That was a great talk. And, it strikes me that this building trust in AI is very similar to building trust in the classic numerical models, actually. So I'm wondering, has there been work on, I think people, forecasters at the forecast offices, they have training on the models, what makes up they have some of the pieces that they don't yet have for AI. But they also don't trust the models for all of their products and all the regimes, based on, again, some of the same things that you've laid out here. So I'm wondering, has there been research on that? And how much, it seems like it would parallel the kind of process that happens.
It absolutely would parallel. So I would say the novelty of this research is not that it's AI, it's that we're engaging end users in the information that they need. So rather than throwing something over the fence and being like, hey, I made this for you, and like, I didn't ask for that. And Julie would be the best person to know about the if numerical weather or more traditional approaches have been used. But something that I will add, one of the treatments that we did for this research was we had information where it said AI training, and then we had another slide deck that said new guidance training. So we basically split people into, they know it's AI from the front, or they don't know it's AI at all. And in the data that I presented here, there was zero difference in if they knew it was AI or not. But quick plug, future paper coming out by Chris, when we go into other parts of the interview, there are not so much differences, but tangible concerns or considerations with whether or not you trust or feel comfortable with AI in the forecasting space. Yep.
Speak loud.
Go ahead, Chris.
Sorry. Thank you, Mariana. I had a question and relates to the conceptual models and how important it seemed that these products somehow aligned with the forecasters' conceptual models. Mm-hmm. And I was wondering if there was a willingness for forecasters to change their conceptual models based on some of the things that they were seeing, or if this was an anchor, the conceptual model was an anchor that was going to be hard to move away from. Because conceptual models are useful, but they're often faulty.
Yeah, that's a lovely question, and also ties into something that I've thought about when I first started this project is, if AI and machine learning is supposed to expose patterns that we previously haven't seen, does that mean we have to rethink how we teach atmospheric science? Like, does the conceptual model have to change? And I would say that, again, these are only 16 forecasters across, the whole US. And there were some forecasters who would say, that doesn't make sense here. But literally one forecaster said, I guess the model's right. And so it shows you that for that specific forecaster, there's this fault, a default, the model is telling them that this, so that they think it's right. And then we have other forecasters who, as I highlighted here, will say, this doesn't match what should be happening with the radar underlay. So yes, and both to your question. Yeah.
Is this on?
It is.
It's on. Yeah. Just a comment. Really, conceptual models are a function of the same process as AI, just people's experience, right?
Yep.
And so, these forecasters have been looking at the phenomena that they're trying to forecast for 10, 20 years, and they, put together their own personal climatology and, baseline information and whatever. So, the trustworthiness in that and AI products, should be about the same, the process of trustworthiness.
I'm going to counter you on that, though, that the AI only sees the data that's coming in. They don't see the people affected by the decision that the forecasters are making. And so the AI doesn't know, I should warn earlier or I should warn later. Sure. So given the, if we're talking purely on a data-based conceptual model, but conceptual models are also informed, how you apply your conceptual model is also informed by the decisions and the people affected by those.
Sure.
Yeah.
Yeah, but the way the conceptual model was developed is
Yes, how it would develop, yes.
was very similar to
Yep.
AI, except AI probably has more specific rules, while people have more range of rules.
Well, there's a whole field of research for behavioral psychology, so there's probably just as many rules in the brain that we just don't know about.
Hi.
Hi.
I'm surprised, but maybe I'm wrong because I came only from the modeling part of these things. But nobody asked for kind of statistical accuracy, objective metrics that they could look into and say, okay, this I can trust, this I cannot trust.
So one of the pieces of information that we provided was a verification slide. And so in in the paper, we have a whole section about the individual slides and how it affected it. So on the verification slides, we did have people say, oh, great, statistics, I can relate to this. We also had people say, oh, Breyer Skills Score, it's been ages since I know how to interpret this. I'm not sure what to do with it. So yes, people liked it and wanted it, and there were also people who were like, I'm not sure how to interpret this correctly. Mm-hmm.
Hi, Mariana. You interviewed 16 forecasters.
Yep.
Would your results change markedly if you used a much greater sample? Okay, that's the first thing. The other thing was I was surprised that when on one of your slides you saw that all the forecasters went in a positive direction. I was kind of surprised. There were no ones that decreased their confidence.
Okay, yep. So I'll do the second question first. So the slide that you're referring to, that was one forecaster's slide. I didn't show you a summary statistic of all of them. So there absolutely were forecasters who had attributes that were in that decreased trustworthiness. So for example, one forecaster, when they were looking at the probability of storm mode, so storm mode was trained on href, and then using additional data, that's how its probability is being predicted. We also provided a slide where storm mode is being trained on href, but then using WRF data for prediction. One forecaster was like, why would you train on a certain data set but then use chunks of data from a completely different model? I don't like that at all. So that's an example of where it decreased their trustworthiness because it wasn't a consistency for them. To your first point about would your results change if you had a higher sample number? Would your ensemble mean change if you had 4 members versus 100 members? What's the answer? Probably. So just like with physical sciences and social sciences, sample size matters, but there's also the consideration of the type of analysis. So with surveys, you can reach very broadly because people are just not clicking a survey saying yes or no. That gives you a broad look, but it doesn't give you a deep look into why they're answering what they are. So that with interviews, one-on-one interviews, we're able to get the depth, so we get the rich, nuanced detail that we can then pair with that broader survey data. So to your question, yes, it would change, but any type of research would have a changed answer if you had a higher N. There's a question in the back.
There's one back there. I'm going to maybe.
So you said that a lot of these forecasters really cared about being able to understand how the model comes to the conclusions that it gives them, sort of how it works under the hood. And to me, it seems like that factor of trust would be really influenced by what specific kind of AI model they're using. For example, like, in a random forest, you're sort of approximating a decision tree, and it's harder to look at a convolutional neural net that way. So were there any overall trends in forecasters' response that changed based off of what kind of model they were being interviewed about?
So when we first started the interview, so this was October 21, it was interesting seeing how forecasters would read convolutional neural net or random forest, and they would say either, I don't know what that means, or like, oh, that sounds familiar. We even had a forecaster say, that says random forest. You guys probably mean to say random forecast. So it shows an unfamiliarity with the models, but interestingly, as our interviews have gone on, like progressing on, and even interviews that Chris has led with our coastal fog, AI has become not just more commonplace in media and the general discourse, but also within weather and prediction. So whether or not they're familiar with it, as in they understand what's going on under the hood, that's a different question of whether or not they've seen it and they can be like, oh, this is AI. But to your question, that would be like if we were to develop a training set or a training document of AI models, that's exactly what would go in there, like explaining how this model works, why is it doing what it's doing.
Thank you.
You want over on the left?
We'll do a few online questions too.
All right, thank you. So, so when we're dealing with forecasters, they're human beings. So if you have 16 person here, let's say, to homogenize 16 women, what are their favorite colors? So they all have their own personal preferences and their personal biases.
Right.
So when we're talking about forecasters, they're coming from different schools, from different professional backgrounds, different countries, different cultures, different genders. So how did we deal with that kind of heterogeneity and came up with a concrete conclusion?
Thank you. So when we did our interviews, we asked them how long have they been forecasting, or how long have they been in the forecasting field? How long have they been a forecaster for the Weather Service? And how long have they been in their current position? So we use that information to then look across the trustworthiness rating, which I can scroll back this way to show you. So on this slide here, we looked at color coding for length of time in National Weather Service, length of time in forecasting in general, and there was no discernible pattern here. So a lower lower trustworthiness rating versus a higher trustworthiness rating, the individual attributes of the forecasters didn't play on that. And I think that's a valid point. Like, we had one hypothesis that we think, younger forecasters are just going to eat up AI. But that wasn't necessarily the case. We had some older forecasters who were like, I love AI. They literally pulled up a Google Doc of all of the different AI resources that they've been looking at. So your question is a point well taken, but specifically for time and forecasting and time with the National Weather Service, we didn't see any patterns come out.
And that is pretty much exactly the first Slido question. So I think we could skip that one. The second one I kind of like here. Was their level of trust impacted by their perception that AI could eventually replace them?
Are you all comfortable with your jobs? Do you think AI is going to replace you? So with the questions that I presented here, that wasn't one that we analyzed, but we do have data which has been analyzed that Chris is leading on how do you feel about AI in weather forecasting. And I don't know, Chris, if you want to give a little teaser of what you've found.
Thanks. Yeah, we use the same data and then a few more forecaster interviews and asked that question, like, what are your concerns about AI? How do you feel about it for forecasting? And people mention, there is a concern about being replaced, but it's really much like, moderated by the perception that we really want to do the best job we can, right? So our whole goal is to make sure our forecasts and all our communication and services we provide are the best possible thing. So whatever tool that we need to use or how we need to do that is most important, right? So there's the concern is there, but it's mostly about like how to do the best job we possibly can. So it's kind of a duality there.
Okay, let's do one more question. Oh, maybe a few more. Your talk was a great amount of time, so we have plenty of time for discussion here.
So one thing I'm sort of curious about is, I think you posit this really valuable model for how these expert users were able to build trust, I guess, in new products and new technologies. And I might be asking you to speculate a little bit here, but do you envision that model of being able to experience a new product, being able to use it, being able to sort of verify it, is specific to these sort of expert end users? Or do you think that's sort of a universal way that anybody, regardless of whether they understand the technology, whether they don't, is able to build trust in new things?
I think that, so if we take away the forecaster lens of this and look at the field, like there's a field called like technology diffusion, and it's, it's a nice S curve. So you have people who are like, I'm gonna be in line for that first iPhone generation 1. And then you have people who are like, I'm going to wait until it's popular enough, and then I'm going to get it. And then you have the late rollers who are like, I've been Android my whole life, but everybody doesn't want to see a green bubble, so I'm going to get an iPhone. And I think the same can be said for any other population with a new piece of technology. So this new model is a new piece of technology for them. So if we were to ask the forecasters, with this information that you've been given, are you going to use it tomorrow? I feel pretty confident in my hypothesis that none of them are going to say they're going to use it tomorrow. But if we say, if you have 5 days to work with it, if you have 10 days plus an actual event to work with it and, like build it out, then I would think that you would then see that S curve of technology diffusion of people who are quicker to pick up on it, those who do it because everyone else in the office is doing it, and then those at the end who are like, fine, I'll do it. But the thing to also think about technology use is it the only piece of information they have? Is this the one severe hail forecast that they have? No. This is one AI tool in a whole toolbox of other pieces of information that they have.
Thanks.
Yeah, let's do one more question.
Hello, thank you. My question's kind of similar. I guess it feels like a chicken and egg scenario where in order to use it, they need to trust it, but in order to trust it, they need to use it. So I guess how do you overcome that initial inertia to get them to use it for the first time so they can trust it?
I would say doing something like this research of having a low barrier to entry, low risk exposure to the product. Like we even had forecasters say, I can't wait to try this. Let me know when it's available. And other forecasters like, let me know when you're doing other research products like this as well. So I think it is providing when I say a safe space, it's like a safe space where their decisions are not going to affect human lives. And also a safe space where they can provide feedback to us and how we can change it, not just us saying, hey, here's this cool new product. So I think that was a great way to end the talk of fund more social science where you're integrating end users' needs.
We have.